Hi, Lonnie.
Hello, Dr. M. How are you?
Yes. Oh, both of us are celebrating Father's Day.
Yeah, good day. It's a good day.
Yeah, nice of the kids to remember us. And then they post us photographs when I was around the time I got married. And I said, I looked at my wife and said, "That's me, right?" So she said, "Yes, that's you." I said, "Fine." That's quite a wicked trick that the kids play on you on Father's Day. They make you look younger, and then you have to look at the mirror and find that you've reached the age. Hey, nice to be back, and let me share screen. And we're going to talk a lot today. Okay, so doing the formalities, Lonnie. So, Lonnie, this is the 23rd episode of the series, Support and Sustaining Continuous Improvement Processes. You have talked to us in the KAIZEN Mindset. That was the part one. I need to introduce you as the principal consultant, owner of Quality Consultants. That's 32 years. And with Chevron for 20 years. BSc Chemical Engineering. Interesting. I was just wondering, how did you stray into Chevron? You were doing a lot of these activities, improvement activities, along with your technical competency.
Yeah. What was your question?
I said you were doing this continuous improvement and the improvement part of it, along with your technical competency when you were in Chevron.
Yeah, in Chevron, I got involved in both the mechanical side of the business. I was in refining most of the time.
Mm-hmm.
And of course, there's a lot of machinery, a lot of equipment, and a lot of opportunities there for things like total productive maintenance, et cetera. And then on the other side, the processing side, optimizing the gasoline yield and making sure all the products are on spec. And that's what an awful lot of chemical engineers do. I had the luxury of being able to do both of them. And then as I became a manager, I managed all kinds of functions, operations, the IT department, the planning organization. That's phenomenal. Planning in a petroleum refinery, engineering groups, both process and designs. And there wasn't very much in a petroleum refinery that I didn't get my hands on, except the steno pool. I never ran the steno pool, So
hey, so great to have you around with all this experience. And this is your latest book on the shelf. You published this month, right?
Yes, I just published that this month.
Mm-hmm.
It's called The Science of Workforce Engagement.
What should be looking into? Is it Science of Workforce Engagement? The EPS.
Yeah, the reason I wrote this book, Doc, is that so many people think of workforce engagement as some magic pop psychology, and it's not. Really, workforce engagement is just good management when you get right down to the bottom line. But there's a science to it, and you'll notice there's that pretty complicated looking graphic on the front.
Yeah,
that's what's called the systems diagram for the science of workforce engagement, and what you need to do to create an engaged workforce. And you'll find out that I'm a huge fan of engagement. And I learned a long time ago that anybody can buy the machinery and anybody can buy the raw materials and anybody can, market the products. But the key is who's doing it. And the key is in the people. And the way to really activate the workforce is to create the proper environment so that everybody can perform to their optimum level. And therefore they can become the best versions of themselves. And once they get there, they will be what we call intrinsically motivated, and you'll be able to do what the subtitle of the book says. You'll be able to turn have to into want to. Now, no longer will the people have to do things because they're ordered, but they'll want to do them because it's the right thing to do for the customer, for the product, for the owners, and for their colleagues as well. So it's all about that science, and it is a science.
Yeah, I like
Yeah.
this. I like this. You talked about the system in this, and then what I like about it is that the concept of engagement from have to want to. I mean, there's a desire to do it. I mean, have to means more of pushing it down their throat, and now this is the happiness of doing it, right? Want
Yeah.
to.
In lean speak,
Mm,
in lean speak, you'd say it's turning a push system, have to,
mm.
pushing it down people's throat, you have to do this, to a pull system. They want to, they bring it to them. And that's what workforce engagement is all about.
And it's be extremely good on the topic that we're going to talk about of engaging the technology part of it. And when
Oh,
they
yes.
want to engage technology, I think we would have hit the bullseye, right? So we're going to hear you talk about it. So here you are. This is the other book that I have. I'm going to buy the book that you published this month. I wish you could convert that into Indian rupees so it's cheaper for me to buy in India. Otherwise, it doesn't matter. So these are the other books that you've written, 5 of them, and sustaining workforce engagement, but that was slightly different from the present one, right? This would be,
Yes.
this is the science of it. The one that you wrote is the science of it. The present one, this is the science of it.
Correct.
And this has become the textbooks these now, how to implement lean manufacturing. These have become the textbooks in many of the colleges and schools, as schools, if I'm correct. I don't know what term that you use in.
Yes, the how to implement lean manufacturing at one time or another was used in 17 different colleges and universities. Currently, sustaining workforce engagement is a textbook in 3 universities that I know of. So they're and they're both very instructive. They're not stories. They're
like a
very
textbook.
instructive, and they're designed to be
A
just
textbook.
that. Pardon?
It'll be more like a textbook, is it?
Well, it is. In the classes, there is one class where sustaining workforce engagement is the key book in which the whole class is centered around it. In the other classes, it's usually an added book that they extract information from the main flow of the course.
That's great.
But it's
And so
used in
this
several-
one will really explain to us all the science behind the thinking that went, or that as a total systemic approach to the workforce engagement. Am I grasping it right?
Yes, yeah.
Spirit of,
You might want to look at the 2 books. Sustaining workforce engagement goes right back to the basic theory
Mhm,
of what makes people move, what is motivation,
mhm,
and it's very deep in the theory.
mhm.
And there's numerous studies that are quoted. And so to understand the deep theory, that's sustaining workforce engagement. You might say the science of workforce engagement is the application of that. And so it's when we take a theory and we apply it, we call those people engineers. They
Mm.
take the theory and apply it to the real world to make the real world a little bit better. And that's what the purpose of the Science of Workforce Engagement book is all about, is to turn normal practitioners into engagement engineers.
Mhm.
That's what we want to create, workforce engagement engineers.
Okay. So I get the theory from sustaining workforce engagement and the implementation from here, right?
Yes.
I'm a good.
That's a
good
good way to
student.
think
I
of
think you should send me an autograph book.
Okay, I will do that. I will do
Okay,
that.
thanks, Lonnie. Okay. So we are on the part 2 of Kaizen Mindset. The part 1 was published earlier. And this came about because we were looking at the Martech Law. and where we are talking about the technology change at the exponential rate and the organizational change at the logarithmic rate. And what do we do with the gap? And your thoughts on that? And I won't take your time. It's all yours, Lonnie. I'm going to stop sharing, and please talk to us about how we're going to cope this sort of a gap, right? So
Okay,
handing it over
let me
to
see
you
if I can pick
and
up
the
the
kinds
screen
of
here.
Kaizen mindset that you require for this. Over to you, Lonnie.
Okay, Dr. M, can you see my screen there?
Yeah, I do.
Okay, good, good. Well, as you mentioned, this is Martech's law. And Martech, well, actually, Martech's not a person. Martech stands for Marketing Technology. And the person who created this was Scott Brinker.
Yes.
You'll see his name down here in the
I saw
corner.
his name, yeah.
And Scott created this graph about 3 years ago, as I recall. You were the one who introduced me to it. And then I got on the internet and researched Scott and his work and marketing technology. It's a fabulous subject. But his point is that, oops, excuse me. There's this huge gap that exists between an organization's ability to change and adapt to these technological changes and the technological changes that exist. Well, being a practical sort of guy, I'm not quite as enthused as Scott is about the size of that gap, because I think there's some other things that in the real world we have to take into account. One is very often this technology is presented like it's a natural good, like it's an answer to the world's problem. And I call those shiny new objects. Okay. But in fact, a lot of the technology is not. And in fact, if you just look at some of your own personal experience, you'll want to say, well, what about the technology that exists that's called Excel? Okay. You and I have Excel on our computers and we use it. But if you look at all of the power, all of the possibility that exists in Excel, the majority of us use 1 or 2 or 3%.
True.
I've talked to some people who are extremely skilled in Excel, and they'll openly admit that they use 5 or maybe 7 or 10% of it. Well, my point is it causes this curve to go up higher than it would otherwise be. And maybe a more practical curve would look something like that, shrinking the gap a little bit. Okay. And then once you do that, okay, then you've got to say, how much of this technology that's good is really usable in my business, in my culture? And I think you've got another curve that goes like this. Okay. And so each one of these things shrinks this gap a little bit below where the concept is of the people who are really enamored to technological change. But regardless, there's a gap. Nobody denies it. But just how big is it, and what should we do with it? I think the people who publish technology treat it like it's just a natural good, that everybody should use it, when in fact there's some complications in using it. Also, I think there's another thing that causes technological change to be seen as a more positive force than it actually exists. And that is, usually when you implement technological change, managers, the people down here, see it as a solution to a big problem. When in fact, the technology itself is seldom a solution to a problem. The fundamental purpose of technology, at least digital technology, is not so much to solve problems, it's to get the information up to a point where we can use it and then can solve problems. Take, for example, Excel. Excel won't solve any problems. Robots don't solve any problems, okay? And things like ERP systems don't solve any problems. So I think there's this other thing that the manager's perspective on it makes these things more popular than if you just observe them and analyze and decide upon them based on their pure merit.
Mhm.
Okay. So they've got what I call a shiny halo effect.
Mhm.
People see technology and they say, aha, that's good stuff. Okay.
Mhm.
And that's almost a knee-jerk reaction.
Mhm.
And a great deal of it is absolutely wonderful. Don't mistake me at all. I'm not anti-technology, but I'm just realistic about it. And I've seen some things. And let me take you back to when I first got deeply involved in technology. I was with Chevron.
Mhm.
And in the 70s, Chevron became a huge, huge technology company. Chevron's based in Southern California. They were right out there in the midst of Silicon Valley. And immediately the people in Chevron started picking up on all the newest and the best technology. And I remember when I was a young manager there, all of a sudden word was going through Chevron about this paperless organization we were going to have. Everything was going to be digitized. It was going to be transmitted via sensors and sent through broadband networks and compiled on computers and sent to you in simple to easy to read reports. And we were going to have, all this information on your screen, and you could read it on your screen, and you just didn't need paper. Well, that rubbed some people the wrong way. So a guy at Chevron actually did a study. And they found out from 1978 to 1985, the amount of paper used in Chevron doubled every year. Well, what they didn't think was this technology. And one of the pieces of technology that was really powerful at the time was Lotus. Lotus came out and it was the first piece of really very usable, very powerful software that you could use on a personal computer. And immediately engineers started doing calculations like crazy. And I remember at one point I was running the planning organization, and we would put together the oils plan for the refinery, and usually it ended up with a 3 or a 4 or 5 sheet document. And we would print it out, distribute it, and that's how we would run the refinery. Well, as soon as Lotus came along, all of a sudden they started doing all kinds of options and permutations, questions that weren't even asked. And every once in a while, they'd stumble across something that was really cool. But what once was 4 or 5 pieces of paper now became a 3-ring binder. Okay. And the amount of paper just escalated. Okay. And so what technology promises conceptually may sound good. Very often it doesn't occur that way. Another thing is enterprise resource planning systems, ERP systems. Some people call them SAP. Sometimes they're called supply chain management systems. But whatever they are, they're designed. If you've got even a modest sized organization, you have an ERP system that's designed to run your business, take care of your accounting, keep track of your suppliers, keep track of your customers, keep your quality metrics, your profit, your loss, the whole business. It's the enterprise resource planning module, their document. And when they came out, it was a revolution in not just the world of technology, but in the world of business. People just saw this as solving so many problems. But if you go to most companies today, they've got this very, very expensive ERP system. Typically, they're $1 or $2 or $3 million just for the software. Okay. And then you have to buy a bunch of hardware to make it work. Okay. And then you have to spend $1 or $2 or $3 million training your people. And when people are faced with all of this, almost always it never comes to pass completely. And so in my clients today, and some of them are tier ones to the automobile companies, you'll find that they use their ERP systems to some extent. But basically the business is run off a series of Excel spreadsheets. Now, those Excel spreadsheets could have been incorporated in their ERP modules if they wanted to. That's a standard feature of just about every ERP system, is that you can integrate it to Excel. You can download to Excel so you can get quick analyses and results. But that's not what they do. And the average manager really doesn't understand their ERP system. Even the planning managers don't understand their ERP system. So here's a piece of just absolutely wonderful technology. It sits out here on Scott's curve, but in terms of where it is in reality is here. The culture really can't use it. And the problem is you have to continually train the people. As people turn over, they have to train and learn how to use it, and they don't keep up with that. So pretty soon it's not used. And what do? Almost anybody can pump out an Excel spreadsheet. So that's what they revert to. And it's a fundamental weaknesses in the ERP systems that they're not transferable from one person to the next. It takes a great deal of energy and effort, and that gets lost. So I'm not as enamored to this set of graphs as Scott Brinker is, although I believe him. I think they're true. Okay. Now, I say that there's a gap, and whether that gap is this big or it's smaller is really not very relevant. Okay. But the gap is caused because the developers have only a superficial understanding of how these pieces of software apply to the businesses, and they apply different. They apply vastly differently depending upon the business you're in. Okay. And they get in love with this technology. It has this halo effect. Managers see it coming and they say, holy mackerel, that's going to solve my problems. And so it gets a lot of energy. Okay. But have these inventors really considered the requirements of the customer? Okay. Why is it that they build this ERP system and 6 months later it's a bunch of spreadsheets? They really haven't seriously considered the issues with their customers. Okay. Okay. And so you've got to ask, what are the motives, what are the intentions, and what are the skills of these inventors? Okay. On the other hand, the managers view this piece of software as a silver bullet. And I think on one occasion I showed you my silver bullet, but here's a silver bullet, Dr. M. This is a real live silver bullet. It's 0.999 silver, and it's shaped exactly the size of a 45 caliber pistol round. But I keep this with me, and I have it in my briefcase, and I give it every once in a while to a manager, and I'll tell him, this is the only silver bullet that exists. Everything else you think is a silver bullet usually is called hard work and effort.
I think you should say that again. The silver bullet reminds me of the comics that I used to read when I was young, the Lone Ranger who uses a silver bullet.
Yeah, that's exactly where the concept of the silver bullet came from. You know, the Lone Ranger, there's a problem, he rides into town. In 30 minutes, he fixes it and he solves it, and he leaves, and the only thing that's left is the silver bullet. He leaves as a reminder that he was there. And that's why managers think. They think they can take this silver bullet called technology, apply it to their business, and in 30 minutes, everything's solved, you know? And it just doesn't work that way, okay? It doesn't work that way at all. It's always people, hard work, effort, energy, success, failure, continuing to work. And the problem with the managers is that typically they hold only a superficial understanding of not only this software, but their entire management system. There are all kinds of things that go on that they are not in contact with, because they don't spend time going to the floor. They don't spend time talking to the people. They interact with the spreadsheets, they interact with their computers, they interact with the email, and they interact with their immediate group of peers who have the same perspective as they do. Okay. And what this leads to is a failure to really have an overall understanding of how this software, of how this technology is going to work in my environment, with my customers, with my products, with my processes, with my people. And that understanding is not held by the managers who need to make the decisions. Very often it's not held by the people who are using the software, which is a sad commentary. But there's this gap. And so how do we go about closing the gap? Okay. So if we look at it, we have what I call top-down issues.
Mhm.
In other words, the people who are top down is from the inventors down. Okay, they really are not clued into how useful it might be. They're not clued into how incomplete it might be. I mean, they may need new hardware, they may need new software, they may need new operating procedures, they may need new, who knows, okay? But they need a lot of stuff to make the software work almost always. And then you've got bottom-up issues, okay? Where the managers overvalue the benefits, they don't understand how to use it. There's an awful lot of things. They don't understand how to maintain it. They don't understand how it interacts with other parts of the system. They don't understand the synergistic and antagonistic effects this has. Usually training is one of those.
Mhm.
They give the people an initial dose of training and then that's it. Okay. So when you take these top-down issues and you look at them, you said, well, if we could solve all the top-down issues, maybe we could cover this amount here in this circle.
Mhm.
And if we could get the bottom-up issues, maybe we could get this curve
Mhm.
from here up to here. And maybe we could get this curve from here down to here. But we've still got a gap.
Mhm.
And that gap will only be covered when these two groups start working together to solve the problems to make this technology as useful as it can be.
Mhm.
This is that overlap is collaboration, it's cooperation, it's cross-functional management, it's getting together and talking about the problems.
Mhm.
Okay. And a psychologist talks about that gap, and he says the people don't talk to each other, they talk by each other. In other words, this person is taking this and talking like this, and this person is talking like this, and they don't meet in the middle. Okay, they're just talking past each other. They use their own jargon, they use their own language, they use their own perspectives.
Mhm.
And that's one of the reasons why a lot of this software does not work very well. ERP is the classic example.
Mhm.
ERP started with the explosion of the MRP modules in the early 80s, actually the late 70s. And so it's not new stuff. It's been around for 30, almost 40 years.
Mhm.
And still it's a huge expense that in most plants is incredibly underutilized.
Mhm.
Okay. So we got the gap. How are we gonna cover that gap?
Tell me, just a layman's question. Now, at some point of time or the other, I'm sure both of us have gone through certain MRIs and certain X-rays, etc. But I've always seen the doctor who actually does the, within quotes, the value adding, have to rely on an interpreter to interpret the images that is given by the highest level of technology. I mean, you get a best of the MRIs, etc. But there is a interface between the person who is valuing add you to it and somebody who's interpreting it. It's not, I mean, I'm just taking a layman's example. It's not the person who has developed the technology of X-ray, MRI, blah, 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 but someone in between that explains in a common language, as you said. They pass by, somebody who comes in. Do you envisage such sort of a thing happening?
Yeah, I just went through that this week, as a matter of fact, Dr. M. I have a problem with my spine. It's called spinal stenosis, and it's a narrowing of the spine that affects the bones just grow because you get old, calcification, and so I asked the doctor what was my problem, and he said, well, on L7 you have severe stenosis. And I said, what does severe stenosis mean? And he said, well, we evaluate it as, what did he call it? Mild, moderate, severe, and critical, or something, 4 categories. And I said, well, we've got some nerves going through a hole. And in your MRI, you can see the nerves, right? And you can see the hole, right?
Mm.
I said, well, is it a centimeter away or a millimeter away, or what is it? He says, well, we don't evaluate it that way. We evaluate it mild, moderate, severe, and extreme.
Mm.
And so this interpreter takes all of these files, these MRI files are gigabytes.
Mhm.
You know, they're not megabytes, they're gigabytes,
Mhm.
and he reduces it to mild. I mean, it's almost absurd. And so I don't know why they go through that interpretation. I guess there's some very special skills that these interpreters have in handling that imagery. Or maybe it's something else. To be honest with you, I don't have even a decent answer for your question, but I do know that they have taken some very, very fine and technical measurements on my spine, and they've reduced it to severe stenosis at L22.
Because I have never seen a doctor actually seeing an image. He always goes by the report that is presented to him. So anyway, I don't know how far that's, would that create a new profession? I wouldn't know. Because there's a lot of talk going around of artificial intelligence, machine learning, and deep learning to be applied at the design stage, and then nothing needs to be done at the operators level or the engagement level. So you get the design right with the machine, with the artificial intelligence, with the machine learning, deep learning, whatever it means. I do not have a clue about it. And then they conclude, you get the design right, and then you don't have to do anything at the Gemba.
Yeah, it bothers me too, because with the case of the doctors going through an interpreter, it's taking the doctor who's making the decision another step away from the data. And you know as well as I do that is absolutely contrary to Genchi Genbutsu, going to the Gemba. You know, go to the Gemba, go to the real place and get the real data. Now, the doctor can't, stick his nose into my spinal column, but the doctor could stick his nose into these MRIs and do all kinds of things with them. I don't know why they need that step in there, but I'll tell you, when I'm solving problems, I don't want that step at all. I don't want that step at all, and I think it detracts from it. And now that you and I are talking, maybe it's just another way to create another profession. I don't know. But I have done some work with medical companies that use MRIs, and I don't know why, they couldn't, as they take these slices and these pictures, you just get incredible images, why they couldn't, count the pixels in the annular space and count the pixels in the nerves and see how far away they were and somehow codify that. But it comes down to, mild, moderate, severe, extreme,
I have seen many of these adjectives used in my case, so I'm quite familiar with those adjectives. It's global. Those adjectives are.
Okay. One of the other things too that I take exception with Scott's statement is that he's talking about technological environment, but he's really only talking about digital technology. If you go to his website and you read and you see the studies that he uses to support this theory, it's all about digital technology. But there's other technology that exists. We have come to use technology almost as a synonym for computerization or robotizing things. But technology is literally applying anything using the scientific method that makes your world a better place. I'm not exactly sure how to characterize that, but maybe that's the best way. And in that sense, lean manufacturing is a technology. It may or may not be computerized, but it's a technology. Six Sigma is a technology. The theory of constraints is a technology. You can use all of those things to make your workplace better and the world a better place. And they are based on science. Hypothesis testing, doing a test, evaluating the results, moving on. It's PDCA in one form or another. And so I kind of take exception to using technology in that sense because it limits us to computers. Now, if you're in the business of selling computers and selling computer technology, that's to your advantage. But if you're not, then it narrows down the field for you. Now, all of these things that come under the category of new technology, I call shiny new objects. Everybody loves them. They're shiny, they're new, they're clean, they're neat. They usually come with a great story, and they also usually come with high expectations. But I have some concerns about them. And some of these shiny new objects are created not because we should be using them, but we can. Okay. Excel is an example of that. When you look at Excel, I mean, if you want to learn Excel, it takes a long time.
Yeah.
But what about the person who wants to get in there and just make a simple spreadsheet that adds, subtracts, multiplies, and divides, and that type of stuff? Does this learning curve slow them down in their ability to use it? How much do we teach these people that they will never use? So I'm not sure that the complexity of all of these shiny new objects are nearly as complex as they need to be. Okay? And you'll notice that's one of the things that we were talking about earlier with that 0.8 of Likers, where he's talking about the Toyota production system. Use proven technology. Okay. And in his text, he talks about using simple technology. Okay. So that's one of the concerns that I have, that sometimes these things are more complicated than they need to be. Okay. The second thing is that each technological shiny new object gets viewed in isolation. Yet to make it work, it must be put into part of a system. So it's a point solution to a system problem. Okay. Even something as broad as ERP is a point solution. Actually, it's a whole bunch of point solutions. But it's trying to address the system of the enterprise. Okay. And so there's other things like robotics. Robotics viewed in isolation sound wonderful. They sound absolutely wonderful. But then you've got to maintain them. You've got to program them. You've got to have very, very skilled people to work on them and keep them programmable. And so sometimes when you put in something like robotics, you need a whole new class of worker. Okay. And so some of these things just do not get implemented as cleanly and as neatly as the inventors see them. Okay. Another one I like to talk about is electric cars. People think of electric cars and immediately the thing that goes to their mind is reduce pollution. And that's true. Well, I think that's true. At least in terms of carbon emissions, it's going to go down. Well, probably, as long as creating the electricity creates fewer carbon emissions than the car does, which I think that's been proven time and time again. But there's other issues. What about roads? Today roads are financed by gas taxes. At least in the United States, they're financed that way. And if you have electric cars, there's going to be a whole lot less gasoline used, which is the objective. So if you use less gasoline, you have a smaller carbon footprint. You also have fewer taxes to build your roads. How are they going to handle that? Okay.
How about the tires?
Pardon?
When the rubber hits the road in an electric car, that also emits enough into the environment, doesn't it?
Oh yeah, yeah. They're not emission free by any stretch of the imagination, and almost all of the electricity is created by not coal, but fossil fuel fired plants. Oil, natural gas is the majority there. So they get, to create that electricity, you're going to need to burn that. Although that's been demonstrated time and again to be substantially less than the emissions that come from the car itself. Okay, but these things can't be viewed in isolation. They're part of a system, and they impact on other things. Okay. The third point is that the perception or the expectation of these shiny new objects is very warped. The benefits are almost always overvalued, and the other issues are undervalued or underappreciated. Again, we're forever in search of this silver bullet. Okay. And when, like you say, the rubber meets the road, there's other things that need to be paid for. Okay? And so, you know, an interesting thing was gas mileage. When Congress started mandating gas mileage in automobiles, they did not get the benefits they expected. Okay. What they didn't consider was that when the gas mileage was improved dramatically, the cost to drive further was reduced. And so even though people got better mileage, they drove more miles. And so they didn't get the expected gains in terms of pollution credits that they thought they were going to get. And so all of these things are integrated into a system. And if we view these things in isolation, or we overvalue, the benefits, we're going to make some bad decisions. Okay. The fourth point is that these shiny new objects must be integrated into the system in which they operate. Okay. And in that sense, I mean physically integrated. If you put in an ERP system, okay, you're probably going to need new servers. You're probably going to need new modems. You're probably going to need new other things associated with the rest of your business. There's always a physical integration of these things. Okay. And that can only be done by motivated, talented people at the source. Very seldom can that be done by the inventors. They'll tell you, well, you need this amount of computing power, and you need a network that can do this, and you need, you know, a peer-to-peer network that can do this, etc. And they can tell you that, but they can't make it work. Okay. In addition to that, in addition to the hardware and the physical stuff, there's all the human elements that are associated with it. You know, I've seen time and again where they implemented an ERP system, and there's somebody in the planning department who's 60 years old and has been using all the old systems, and now they come along with all this new software and stuff, and they're not comfortable with it. They can't deal with it. And it's not unusual for these people to say, hey, I'm too old. I don't want to learn all this stuff. And so they just retire. And now you've lost some resources. You've lost all the intelligence that they've gathered over the years about the system which they're planning for. And so you always have to integrate it, not only physically, but culturally into the people themselves. And kind of my overall point is that each shiny new object is usually a point solution to a system problem. And it must be incorporated into all of the elements of the culture, the physical, the emotional, even as far as being integrated into your customer's acceptance of it. A lot of times these computerized systems impact on the process itself. And very often that might require approval from your customer to change it. These items, when you put them all together, come to play in what I call the emerging technology hype cycle. And let me show you that for just a sec. You've seen this, Doc, I know. But what the hype cycle is it's a graph of expectations on the y-axis over time. And so when people first look at some new piece of innovation or technology, okay, immediately their expectations take off like a rocket. Now there's tons of little pieces of examples in here that are put on this timeline, and I'm going to ask you to ignore that and just look at the overall shape, if you would.
Mhm.
But what happens is early on, expectations are very, very high.
Mhm.
But as people get along, pretty soon they realize we need some hardware. We need to change the way we're training. We need to change our software. We need to, oh my goodness, we need to change this. We need to change that. And pretty soon when reality creeps in on them, they
Mhm.
say, holy mackerel, we've got a lot of stuff we've got to do to make this shiny new object productive.
Mhm.
And so they go through all of this learning and this trial and error and this expectation. And then finally they get to the point they say, aha, we're making it work.
Mhm.
Now it's working. Okay.
Mhm.
And they can take off. And if that's your environment, okay, and you're using problem solving by engineers, for example,
Mhm.
engineers and managers, you're going to have a curve like that.
Mhm.
If you've got a true Kaizen culture, which is what we talked about earlier,
Yeah.
now this curve looks a little bit different. It probably doesn't go down here. It goes more like this. And if you've got a really, really healthy Kaizen culture, it goes like this.
Okay. Can I just interpret based on
Please.
the Kaizen mindset part one that we said? The blue line, when the engineers come into play using the technology, they're comfortable with that, and they tried implementing it. You get into the line, the red line, just above that or more above that. That is, you are establishing a new standard, right? The one that you spoke about in
Yes.
Kaizen mindset. In
Mhm.
when you are improving the standards, right? By
Yes.
we called it a Kaizen event at that point of time, but here we are just talking the same thing with the use of technology that you raise the standard up. Am I
Yes.
gathering it right?
Exactly. Yes.